Good morning, class. Sorry I'm homesick. I just wanted to leave you this little video so that you could have something to kind of watch and listen to help you figure out this lesson. We're going to start chapter 3, and in chapter 3 we're studying derivatives. And if you remember, we've already kind of mentioned that word. The last lesson that we did, 2.4, is basically the exact same thing that you're doing in 3.1. The only difference is we're going to definitely start calling things derivatives now, and we're also going to use notation. So that's kind of some of the things I'm going to walk you through. What I have pulled up are my teacher notes, and they're all filled out, but I still wanted to kind of point some things out too. So you'll want to go in and copy these things down in your notes, or you can do it as I'm reading through this, but be listening to a few of the things that I'm going to mention. Also, if you notice, there's a little video right there on the difference quotient. Remember, you can go to those to my website, and these are on the tutorial link, and it's the calculus phobe. So you might want to check that out too before you start. Okay, so here in this yellow box you have the definition of the derivative. We've already seen this before. This is exactly what we were doing in the last lesson. So we know that this is how we find the instantaneous rate of change, aka the slope of the tangent line. That is called the derivative. Notice this notation right here. We're going to talk about that here in just a second. Okay? All right. Here's a couple reminders about what a derivative is: slope producing formula, instantaneous rate of change, slope of the tangent. We've heard all of that before. Okay, the important thing, or really the only thing that's different, are these derivative notations. So here, this first one, this is the notation, number 1 there, that we will use the most. We say this is f prime of x. So if they give you a function f of x and tell you to find the derivative, then the notation you would use is f prime of x. The second notation here, number 2, is y prime. So you would use this notation if the function that they gave you was called y. There's literally nothing different between number 1 and number 2. These are just two different notations that you can use for derivatives. If they give you the function and they call it f of x, then you'll use the first notation, and if they give you the function they call it y, then you'll simply use the second notation. There's really no difference between them. There's two other options, which are number 3 and 4. On number 3, you could use this notation as well if they gave you the function y. Instead of calling it y prime, you could also call it dy dx. This notation is the best notation because it tells you that you're taking the derivative of the function y with respect to x. So this notation tells you not only what the original function is, but it tells you you're taking the derivative with respect to x. In other words, y is a function of x is the independent variable, y is the dependent variable. So number 3 is the best notation. Okay, and then last, just a different notation. We can't just have one way to do something, so we have 4 ways to do it, but there's, again, no difference between these. On number 4, what we're doing there is if you have a function f of x and you're taking the derivative, you can use this notation as well to show that you're taking the derivative of this function here with respect to that variable. So again, 4 ways to do the exact same thing. Okay, so all of these 1 through 4 are the notations for derivatives. The next thing says derivative at a point. Okay, so if you were asked to find the slope of a tangent line when x equals 3, for example, you know that you would need to find the derivative, aka slope producing formula, and then you would need to substitute in 3, right? So the way that we do that is we don't say f of x. Once we find f of x, we then will write, once we find f prime, aka the derivative, then we'll substitute 3. And so then the correct notation would not be f prime of x, it would now be f prime of 3. So we'll look at that here in just a second. You could also write it this way if you were using the third notation. So dy dx when x equals 3 is the way that you say that. Okay, I know that all sounds very confusing right now, but that's actually very, very simple. It's just the notation, which means this is just how we're going to write things. It's not a big deal conceptually. It's just basically making sure that we are being precise and communicating the right way. So we'll look at that here in a second. We'll talk about this Newton-Leibniz controversy tomorrow when I'm back. It's basically some controversy over notation. Okay, one more thing, and then we'll look at the examples below. There's another definition. These are always really important. Okay, it's in the yellow box. This is the definition of differentiable. It says a function is said to be differentiable at x if that limit exists. It's a really fancy word, and we already actually know what it means before I read that to you. Differentiable just means that a function has a derivative. In other words, for some function, say y equals x squared, if we think about that graph, we know that at any x value we pick, there is a derivative, right? There is a tangent line that you can draw and a slope that you can find, right? So for y equals x squared, we would say that this function is differentiable everywhere, because at any x value we can draw a tangent line and find the slope. Okay? So differentiable just means that there is a derivative. There is a tangent line and you can find the slope of it. Some of the directions on the homework will say find the derivative. Some of them will say differentiate. These are synonyms and they mean the exact same thing. Okay? All right. Again, might sound a little tricky, but once you look at this, hopefully you'll see. Okay, so on example 1, if you take a look here, I'm going to try and scoot this over a little bit. There we go. Okay, so look at example 1. It says find dy dx if y equals 4x plus 1. So again, when they use this notation, they're just telling you to find the derivative. Okay, that's all that that means. Notice, guys, they're doing the exact same thing as we did in 2.4. Oh, there's my child. Okay, baby, thank you. Okay, so notice this is the exact same thing. The derivative is down here, and it is 4. Okay, which we knew that, right? We knew the derivative would be 4. All right, let's take a look at B. Same exact thing. They want you to find the derivative. They're just using a different notation. That was the number 4 notation there. Okay, so if you notice, we're still doing the exact same limit. Nothing is different there. Multiplying to get common denominator, and then down here is our derivative. Okay, nothing's different except notation. All right, the last problem. Now they're using this fancy word. It says differentiate. That simply means find the derivative. Okay, since the function was labeled f of x, they wrote f prime of x. I wrote that, but that's what you would write. Okay, there's your derivative right there. That's the slope producing formula. Okay, now if you finish reading the question, it says find the equation of the tangent line to f of x when x is 9. So now look what we do. We go down here and we say f prime of 9 equals 1/6. This means right here that for your function f of x equals the square root of x. Okay, if you think about that graph, there's your graph. When x is 9, right, way down here, you'd have a point at 9, 3. That would be your point. The slope of the tangent line at that point is 1/6. That's what that means right there. Okay, then if you continue reading on in the problem, it says find the equation of the tangent line. Okay, and we know how to do that. I didn't finish that, but you can do it. The point is 9, 3. The slope of the tangent is 1/6. And then you can simply get the equation of the tangent line. Okay, guys, that's pretty much it. Down here on the bottom, there's a couple other formulas that sometimes are used. If you look at this one, that one looks a little different. This one's pretty much the same as what we've been dealing with all along. If the directions in the book tell you to use, you know, maybe this formula here, or I think they do one similar, but they use A's, you don't have to use that formula. You can just simply use this one over here that we've been using all along. Okay? All right, fill in your notes. Watch this video again if you need to. Watch the video that's on that video tutorial of the difference quotient if you need to. And then 3.1a problems. Go ahead and start working on those. I'll see you guys all tomorrow.